Alright, so let's work out an improper integral and tell if the integral converges or diverges. So let's look at the integral of 6 over x to the 4th dx from 1 to infinity. Alright, so this is equal to the limit as b approaches infinity of the integral from 1 to b of 6 over x to the 4th dx. Alright, so if you want, you can write that as 6x to the negative 4 to help you do your integration. So it's equal to the limit as b approaches infinity of, now whenever you integrate, you're going to get, add 1 to the power, that'll be negative 3, divide by negative 3, so that's going to be negative 2 x to the negative 3. Alright, and that's going to be evaluated from 1 to b. So that's the limit as b approaches infinity of negative 2. Now plug in a b. Negative 2, if that's b to the negative 3, that's the same thing as over b to the 3rd. And then you have minus. Now plug in a 1. 1 to any power is 1. So that's minus negative 2. Alright, minus the negative, you can go ahead and make that a plus. So now I just have this limit to do. Let b approach infinity. Negative 2 divided by infinity is 0. Plus 2. So my answer is 2. So the integral converges to 2. Or you could just say the integral converges after you get your answer. Alright, let's look at this one. The integral from 1 to infinity of the natural log of x over x dx. I'm always looking for u's and du's with integrals, especially if they don't fit any formulas right away. And so if I let my u here be natural log of x, then my du is what? 1 over x. I have a 1 over x present. So that means this is actually just the integral of u to the first power. So I'm gonna write this, the limit as b approaches infinity of the integral from 1 to b of, now this is u du. So that's the limit as b approaches infinity of u squared over 2. And I do have to plug my u back in. So that's the limit as b approaches infinity. My u was the natural log of x. So this is natural log of x squared over 2, evaluated from 1 to b. So this is the limit as b approaches infinity of the natural log of b squared minus, and there's a 1/2 in front, minus 1/2 natural log of 1 squared. That's 0, so that term is going to go away. However, there's no way to rewrite this, and so I'm going to have the natural log of infinity squared. Natural log of infinity is infinity. Squared is infinity. Alright, so the integral diverges. Alright, let's look at this one. The integral from negative infinity to positive infinity of 4 over 16 plus x squared. So I'm going to choose on this one to break this up at 0. You might want to make sure that whatever you choose is going to fit the integrand that you're going to get. So what type of integral is this? It's an arctangent integral. So whatever c I choose, I need to make sure that I can easily evaluate it in arctangent. And 0 is a very convenient value to do so. You could choose pi over 2. I mean, you could choose different things. Pi over 2 is probably not the best, but you could still work it out. But I'm going to choose 0. So this is going to equal the integral from negative infinity to 0 of 4 over 16 plus x squared dx plus the integral from 0 to infinity of 4 over 16 plus x squared dx. So here I'm going to let the limit, I'm going to say the limit as a approaches negative infinity of the integral from a to 0 of 4 over 16 plus x squared dx. Here I'm going to say plus the limit as b approaches positive infinity, the integral from 0 to b of 4 over 16 plus x squared dx. Alright, so let's work this integral out real quick. I have a constant of 4 in the numerator. So let's see, that's going to be 4, and then my a is equal to 4, and my u is equal to x. So it's 1 over a arctan u over a plus c, but it's a definite integral, so I don't put plus c. So it looks like I'm going to have arctan x over 4. That's going to be my answer for both integrals. So this is going to be the limit as a approaches negative infinity of arctan of x over 4 evaluated from a to 0 plus the limit as b approaches positive infinity of the same thing, arctan x over 4, but now evaluated from 0 to b. Okay, so this is the limit as a approaches negative infinity of the arctan of 0 minus the arctan of a over 4 plus the limit as b approaches infinity of arctan of b over 4 minus arctan of 0. So now all we have to do is try to figure out what all of these arctans equal. The arctangent of 0 means the tangent of what is 0. That's 0. And then that's going to be minus the arctangent of negative infinity. Okay, so if you recall the graph for tangent, it goes like this. You have a vertical asymptote here at pi over 2. You have a vertical asymptote here at negative pi over 2. And arctangent is defined between negative pi over 2 and pi over 2 generally. So there's a couple of answers here. That would be 3 pi over 2, and we know it's going to cross here again at pi. Okay. Minus, all right, so the arctan of negative infinity. Generally, if arctan is defined between negative pi over 2 and pi over 2, and usually we don't let it be the endpoints, but that's because it can't actually be, but we're letting a approach negative infinity, and so we would get this value right here, this negative pi over 2. Alright, plus arctan of, that's infinity over 4, so arctan of infinity, we generally go with pi over 2, because you can see it's approaching positive infinity there. And then minus arctan of 0 is 0. So you can see I have minus a negative here. Alright, so that would be plus, and so pi over 2 plus pi over 2 would be 2 pi over 2, or just pi. So that's one way to work it. Of course we're right, we're always right. We checked the book and it was right.